All right, so we've got two tools now. We just have to figure out when to use. Moles of water cancel, and look what I'm left with, grams of water. So my answer is, this video is going to introduce mass into our stoichiometry problems. So let's just review the conversions that we already know how to do. First of all, we know how to convert grams of a substance to moles. We're just going to multiply by 1 mole of A per question mark grams of A. And why do I use question mark there? Why can't I write a number in there? Well, it depends on what A is. This is molar mass, right? Upside down. Molar mass is the mass in grams of 1 mole of a substance. Now, I'm going to use that same relationship to convert from moles of A to grams of A. So in this case, I would multiply by grams of A per 1 mole of A. All right, so what are those two ratios? What is that? That is your good friend molar mass. And where does molar mass come from? Not from a chemical reaction. It comes from your periodic table, right? You know how to add up the molar masses of substances. All right, and then the new ratio that we've learned is our mole ratio. And that would be, if we have moles of A, we're going to moles of B, we'd multiply by the ratio of moles of B to moles of A. And where does that come from? This is what we call the mole ratio. And this comes from the equation. Comes from the balanced chemical equation. All right, so we've got two tools now. We just have to figure out when to use them. We've got molar mass, good for conversions, and we have mole ratios, which are good for other conversions. So let's do an example problem. So I'm going to start with moles of water, and I'm going to find grams of hydrogen. Okay, mass means grams of hydrogen. Okay, so let's go ahead and write the given. I've got 3.7 moles of water, and I want to go to grams of hydrogen. Can I go there directly? Can I trade in moles of water for grams of hydrogen? I can't. I've got to go to a new substance, so I need to use my molar mass. Okay, molar mass is the one that goes from one substance to another. So let's do a mole ratio and get 2 moles of hydrogen. So where do those numbers come from? From the balanced chemical reaction. So I've got a 2 coefficient for hydrogen and also a 2 coefficient for water. So when we stop right here, if we stopped right here, we would be in moles of hydrogen. Now, how do we get to grams of hydrogen? Well, we're just going to use molar mass, right? We're going to trade in moles of hydrogen for grams of hydrogen. All right, and molar mass is, for 1 mole of hydrogen, we have 2.02 grams of hydrogen. Okay, so when we multiply here, moles of hydrogen cancels, and we're going to be left with grams of hydrogen. Okay, and the answer would be twice that. Let's see, that would be 7.5 grams of hydrogen. Okay, so let's just review what we used. The first ratio we used was a mole ratio. Why? Because we started in moles of one substance and we were going to another substance. The next ratio we used was molar mass. Why? Because we didn't want to leave it in moles, we wanted to go to grams. Let's do another example. All right, this time we're going to start with mass. We're starting with 12.5 grams of oxygen, and we want to know the grams of water. So how much water can you produce from 12.5 grams of oxygen, and then excess hydrogen? That just means you have plenty of hydrogen. All right, so let's just start with the given. I've got 12.5 grams of oxygen. Now, can I use my mole ratio because I'm trying to get to water? I can't. I've got to get to moles first so I can use the mole ratio. So first step, is molar mass. Get rid of grams of oxygen and we'll go to moles of oxygen. Okay, this is the mole ratio. I'm sorry, molar mass. I'm just going to put parentheses around it. All right, so diatomic oxygen, 1 mole is 32 grams. Okay, next step. Now, if I stopped and multiplied, I would be in moles of oxygen. Where am I going? I'm going to water. So I need a mole ratio. So get rid of your moles of oxygen and trade that in for moles of water. Okay, now where do the numbers come from? This one's great, comes from the reaction. So I've got a 2 in front of the water and I've got a 1 in front of the oxygen. Okay, now if we stopped right here, where are we? We're in moles of water. Are we done? No, I need to go to grams. So one more step. Can I trade in moles of water to grams of water? Okay, so this is the molar mass of water. 1802 is 1 mole. Okay, so moles of water cancel, and look what I'm left with. Grams of water. So my answer is, I literally work out the whole thing and then I pick up the calculator at one time. And my answer is 14.1 grams. Okay. Now sig figs, I started with 3 sig figs and I want to end up with 3 sig figs. Now let me just review the steps that I just did. First, I used molar mass. Okay, why did I use molar mass? Because I had to get to moles. I started in grams, I had to get to moles. And then what did I use? This is the mole ratio. Okay, the mole ratio is what's going to convert from one substance to a different one. And then what's my last trick here? I used another molar mass. Why? Because I needed to get to grams. So you have 2 tools. Mole ratio goes from moles of one thing to moles of the other, and molar mass gets you back and forth between grams and moles.